So in this video, I want to discuss data and explain how data trees, and data structures work. Not just in Grasshopper, but in general. But of course, I'm going to focus on mainly how it works in Grasshopper, so that uh, it's easier to understand for designers and architects. The reason why data is always so sort of difficult to understand, especially to designers and architects, is because we don't have a programming background, and we haven't really dealt with data a lot. And the way data is used and organized when it comes to computers is fairly different from what a layperson would understand. And that's why there is that sort of gap between our understanding of data and how it's really used. So to start off, of course, the image that you see right now um, is a view of the data viewer component in Grasshopper, which is showing a whole jumble of data. It's a really complex data tree, and the chances that you'll have to actually deal with something like this are I mean, it's fairly um, it's really rare that you come across such complicated data, and mostly, you it's best if you're in control of the data structures that you're working with always. So to start off, I'll just start with a quick real-world example, a sort of analogy. Imagine if you're a teacher and you need to give your class a group assignment or something, right? You have a bunch of students, and you need to assign various groups and assign projects to those groups. And each project might have like a different size of students, size of group, and so on and so forth. So like how the way you would approach this problem is, first you would organize your students, right? Throw in a little social distancing, and then you would start actually assigning projects based on which students have what interests, and so on and so forth. And similarly, when it comes to geometry, so for example, if you have 4 points and you want to create a rectangle out of those 4 points, you basically just join them and close the rectangle. But if you have a whole bunch of points, say in this case 12 points, then you have a problem, because you need to first organize these 12 points into groups of 4 each, and then you can join them to make your rectangles. So of course you wouldn't use definitely would not want to use this method of organization, right? Because here you still don't have that segregation of 4 each. So this is what you want, where you have 4 here, 4 here, and 4 here, and you can easily use these to make your squares or rectangles, right? Now, the way this is done in computers, since of course computers are dumb, they need to be told what to do. So in order to communicate how to handle the data to the computer, we use the concept of lists and trees. So essentially, each item is you can imagine it as a leaf, and multiple items make up a branch, a list, or a branch, and multiple branches make up a tree. So of course right now this might seem a little confusing, but let's take a look at how items, lists, and trees work in Grasshopper. So here 99 is the item at index 3. Indices start always with 0. So 99 is the item at index 3 in this list. So this is one item, right? And multiple items make up a list or a branch. And multiple branches make up a tree. So if I was to tell the computer to refer to that item 99 in this tree, I would tell it to refer to the 0th branch and the 3rd item in that branch, and so it would know that I am referring to 99, this item. So for a better understanding, let's say you have a tree with 3 branches and 1 item each on each branch, right? And you have another tree with again 3 branches but 2 items on each branch. Now here's where branches and lists become useful. For example, if you want to create a triangle, say each of these items is a point, right? So you want to create a triangle between using this point and these 2 points, this point and these 2 points, and so on, right? So you will basically merge these, and when you merge these 2 trees, whenever you merge trees of the same structure, you will get another tree with the same structure. So here we'll basically, let's give these branches indices. So this is the 0th branch, the 1st branch, and the 2nd, 0, 1, 2, and so our output structure will also be similar. Now on each branch again we have items, so all of these are of course just 0. This is 0, 1, 0, 1, 0, 1, right? Just to avoid confusion, these are my branches and the ones without brackets are the indices, the items. So when we merge these two, we will essentially get this item first on this branch, then these two on the same branch. So 0, 1, 2. So the 0th index of this branch has now become the first index on this branch, and the same for each of these. Now what's interesting now is that I can then use these to create triangles in the same data structure, and so I'll have the same structure, but now these will become triangles. Right, now let's say I introduce one more here, right? That when merged will come here. And so if I'm not just making triangles but actually polygons, then that polygon, this polygon will basically be a quadrilateral. So this is basically the use of trees, and why trees are used is due to this reason, that it's easier to explain to the computer how to actually handle data and how to use the data in a meaningful way and not lose the meaning of the data. Because if you look at the other alternative, you would basically have just a bunch of points, and you would want to create particular polygons out of those points, but you don't know how to tell the computer to actually refer to these points individually. Of course, you can give indices to each of these and then refer to that 0 plus 2 plus 3 is our first triangle, and so on. But it becomes much more easier to deal with the data when you actually use tree structures and branches. So again, coming to Grasshopper, we have the concept of flatten and graft, which eludes most people's understanding. So again, I'll come to this diagram again. I'll just explain quickly what flattening and grafting means. So starting with flattening. Now, for example, if you have a tree, a really huge tree, right? You have various items and even sub branches or whatever, right? And now you want all this data, but you don't want the structure anymore, right? You only want the items and in the same order in which they occur. So say this is the 0th item, the first, the second, third, and so on. You want it in the same order. So flattening it basically gives you like autumn, right? It gives you a pile of these items in order, of course, but without the structure. So if you had a tree that sort of has various branches, you will just simply get all the items in each of those branches in the same order in which they occur here, but without the actual structure. So flattening basically removes all the structure. Now, on the other hand, we have grafting. Now, grafting is, I wouldn't call it the opposite of flattening, but almost the opposite of flattening. So let's say we have a pre-existing data tree, right? And we have 2 items in each branch. Grafting this simply takes each item and gives it its own branch. Or in other words, it adds another layer of structure to the entire data tree. So if here I had 0, 1, 2, and my items were 0, 1, 0, 1, 0, 1. Now I have 0, 1, 2, and then 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, and then 0, 0, 0, 0, 0. Now, what I just explained here, the 0, 0, 0, 1, 2, 0, 2, 1, these are called addresses, or sometimes even data maps, or the path of items. It has various terms, but it's essentially the human readable way to refer to a particular branch or a particular item. So it's like addresses in real life. So for example, you're Rahul, who lives in Delhi, and you have a friend, Rishabh, who also lives in Delhi, and you each have you have 2 other friends, and you each have addresses, house number so and so, street so and so, even floor so and so, and city, and then state, then country, and then continent, then planet, solar system, galaxy, whatever. Right. Now, if you are to refer to each other, so if for example, my data only consists of people who are inside Delhi. I don't need anything beyond, let's say, state, right? This is all redundant for me because is the same for each of these uh, items, right? So when I refer to, say, Rahul, I will say he lives on floor so and so, house number so and so, street, then city, then state. And the same for this guy, the same for this guy. Now, if suddenly Raj is in Bangalore, right, his address would be different, not just till here. So for these three, the address would only vary here. But for Raj, it would also vary here, say, because he's in Bangalore. So it would actually vary this much. This would also, the entire sort of address of Raj would be different. Whereas these three would have this portion in common. Maybe they're in the same city, maybe they're just in the same state. So then, because of this comes in the concept of simplifying the data. So there is a function in Grasshopper that's called simplify data tree. So that basically removes any redundant data path, the part of the path that is redundant, and gives you only the structure of the data in a form which is relevant and has only the useful part and not the redundant part. So you now know how grafting works, how flattening works, how simplifying works, and basically these three are the most essential to everything. And of course, I've also covered merging of data trees, which basically means that if two data structures are the same, then the items will just simply be put onto the same structure with the order maintained, and yeah, that's about it. The other concepts are sort of derived from these. These are basically the very basic operations that you can perform on data, and yeah, with these you should be able to manage your data much better. Now, coming back to this diagram, so here we have a structure of data that has 5 items in the first branch, 3 in the second, and 6 in the third. Again, if you want to know the count of your items in the branch, just look at the last index and add 1, because the first index is always 0. So if we flatten this, we will essentially get just these items in the same list. So here I'm following this item 99 again. And let's say we have another flattened list. And if we want to essentially merge these two, then if we can simply graft both the lists, and we'll get sort of each item in its own branch. And now when we merge these two data structures, you see 77 has been paired with 91 on the same branch because their path was the same initially. And so 40 and 82, 17 and 19, 99 and 57. And so there, our item is on the third branch. Right? And you can see it was the third item, and so it's the third branch. And in Grasshopper specifically, even the wires, if you turn on raw fancy wires, they will basically let you know what kind of data you're dealing with. And so like a single wire, single line basically means that it is only one item. A double line means that it is a list of items, and a list is basically just a branch without any other structure, but just multiple items in a ordered list. And the dashed line, dashed double line, means that it is a tree of data. And so this basically will help you, without having to actually see what kind of data you're dealing with. You know that if you were expecting to have only a list and there's a tree coming in, you can always simply flatten it, and your results might improve. And now coming back to this example that I was talking about, where you have 4 points and you make a quadrilateral, you will need to tell the computer that, if you have 12 points, you want to have, work with those points in this particular way. So in Grasshopper, if you have that same, if you basically want to execute that, then let's say these are your, ignore these actually for now. Let's say that these are your 12 points, and so when you merge these 12 points, you will basically, merging items gives you a list. So here, this basically, this line denotes that it is a single item, and merging it will give you a list. So here we have basically a list of 4 items, which is basically just a branch with 4 leaves. And once I once I graft this list, it will essentially give me a structure that looks like this, with 4 branches and 1 item on each of these branches from these indices. So 0, 1, 2, 3 becomes 0, 1, 2, 3. Now, when I merge these 3, let's actually draw those out. And this is my merged tree. So what it's going to do is it's going to take the items at the same indices and going to put them on the branch that they belong on. So it'll take the 0th branch, and it'll draw all the items that occur there on the new 0th branch. So I have 4 items here in the order. So if this is my, so this will basically be 0, 1, 2. There won't be this one. Yeah. Right. And similarly 0, 1, 2, 0, 1, 2, 0, 1, 2. So this is my new structure. Now you might notice that I have 4 branches and 3 items on each branch. If I use this in a polyline component, if I plug this data in directly here and not use this flip component, I will basically get something that looks like this. Of course, here I have 4, but I mean, you get the idea, right? If I had 3, then it would basically join the first of each of these 3, then it would join the second of each of these 3, which is something that we don't want. So how do we fix that? If we take a look at the data structure again, but this time in a tabular form, we will see that it's currently organized this way, that there are 4 columns, and it's basically organized this way. And here each of these branches are my columns, and each of these items are in each row. So 0, 1, 2, 0, 1, 2, 3. Right. So I want to use each of these yeah, no, I'm going back. Fine, yeah. So I instead don't want to use these branches, these as branches, but I want to use each of these rows as branches. So if you remember, I think 11th standard maths, there is a concept of transposing matrices where you essentially invert the columns and rows so that your columns basically become rows, and so it'll, instead of becoming a 4 by 3 matrix, it'll become a 3 by 4 matrix. So that is what we need to do here in order to get data that looks more like this. And what this will do to our structure is basically it'll, instead of giving us 4 branches and 3 items on each branch, it'll give us 3 branches with 4 items on each branch. Right, at this point you must be confused about the order of these items. Well, it'll take the 0th item from each branch, or the first row from each column, the 0th row from each column, and put it onto the new 0th column or the 0th branch. So this item, this item, this item, and this item will be put onto the first branch. Similarly, the first of each will be on the first branch, and so on. So now when I join these vertices using the polyline component, I will get what I expect. So this is just basically an example showing how understanding how your data trees look and work can really help you very quickly understand where you're going wrong and what you should change, or flatten, graft, simplify, merge, or flip when you to basically get your final expected output. So yeah, essentially the concept is around the idea of leaves, branches, and trees. So yeah, that's about it. If you have any queries, any comments, please feel free to comment below. And yeah, thanks.